Assalamualaikum class. We continue our lecture with chapter 1. Determine the number of significant figures in the following measurement. So, we need to determine how many significant figures here. For example, here I just give answer for question number 1, 478 cm. So, the number is 3 significant figures. And the rest one you can do by yourself. Okay, significant figures in calculation. So it has some of the rules. For example, for multiplication and division, the reported result should have no more significant figures than the factor with the fewest significant figures. So how to solve this type of question? When you have 1.827 meters times to 0.762 meters, what is the answer for this question? Okay, 0.762 has 3 significant figures, so the reported answer is 1.339 meter square. Here is a 4 significant figure and here is 3 significant figure. So the answer should follow 3 significant figure. For the lowest, the smallest significant, fewest lah kita panggil, the fewest significant figures. Here is 4, here is 3. So the answer should follow the fewest one. And for the addition and subtraction, the reported result should have the same number of the decimal places as the number with the fewest decimal places. Okay, for example, here the decimal places here is 1, 2, 3. Here is 1, 2. So at the end of the calculation, so you need to round out the answer until you get the fewest decimal places, which is 2 decimal place. And be cautious of round-off errors in multi-step. Wait until calculating the final answer before rounding. So the rounding process should be at the end of the calculation. Do not round at the middle of the calculation. You need to round the answer at the final of the calculation. So what is the uncertainty? Well, uncertainty is we call as an error, or we call any measure or calculated value has some uncertainty in the reported value. And this does not refer to mistakes, but rather an avoidable error due to the nature of the experiment. And for example, if you were measuring the width of a grape, using a ruler, you might report a value of 12.3 mm, but there would definitely be some error incorporated in the last digit because grape is round shape. So if you use a ruler, the ruler is not an appropriate equipment or tool to measure the round shape. Basically you need to use measuring tape. Okay, therefore it is important to indicate the uncertainty in any measurement, and this is done by recording the certain digits and the first uncertain digit, the estimated number. For example, using a measuring cylinder, 26.4 plus minus 0.1 ml, and using a burette, 24.40 plus minus 0.01 ml. So the precision by using the burette is more precise compared to measuring cylinder. Okay, no measurement is exact. There is always some uncertainty due to limited instrument. Accuracy and difficulty reading result and estimated uncertainty is written with a plus minus sign. For an example, 8.8 plus minus 0.1. And the decimal place for the uncertainty is followed by the how you write the value for your your measurement. N% of uncertainty is the ratio of the uncertainty to the measured value multiplied by 100. So you should put 0.1 is referring to uncertainty divided by 8.8 is the value for your measurement times 100%, and you get the value for uncertainty is 1. The value of uncertainty is 1%. When n accepted or standard value of the physical quantity is known, the percent error is calculated to compare an experimental measurement with a standard. So if you want to determine the percentage error, you need to subtract the value of the experimental with the standard value divided by standard value times 100%. So for this calculation, you can determine the percentage of error. Okay, what is a scientific notation? Scientific notation, the purpose of the scientific notation often used to express very large or very small numbers. Also used to maintain correct number of significant figures. If the number is too small, for example, nanometer, so if you convert to meter, it will be 10 to negative 9. If mega is larger scale, so it will be 10 to the power of 6. N is a number between 1 to 10, and n to the power of n is a positive or negative integer. And it can be from 0.000205, or here is the example of 10 to the power of negative 5 in negative integer. And a number between 1 and 10. And here is to the power of 10. Okay, the power of 10 has two parts. There is a base and there is an exponent. Here is the base always be 10. It could not be 9, 3, 2 or any number rather than 10. It should be 10. And this is the exponent. Exponent can be any numbers. So, nombor bulat lah. Is it negative or positive? If decimal point had to be moved to the left, exponent is positive. If the decimal point had to be moved to the right, exponent will be negative. Addition and subtraction must be converted to form in which all the exponent have the same value. Okay, for example here, 4.31 times 10 to the power of 4, you need to solve this part first because here is multiplication. You need to solve this also multiplication part. When you get this answer and also this answer, you can add between this answer and this answer to get this answer. And for the multiplication and division, you need to multiply first n1 and n2. You need to multiply first and add exponent n1 and n2. Means that if here is also multiplication, you can directly multiply. 4 multiply by 7 and times multiply. Here is 10 to the power of negative 5 plus. Here is positive, you need to plus 3. So at the end of the calculation, you get 28 point to the power of negative 2. But here is you move to the left. So here you need to put plus 1 because you move to the left. Plus 1 and you get here negative 2 plus 1. So you get here negative 1. And the division, divide n2 and n1 and n2, subtract exponent n1 and n2. So you can directly do the division between 8.5 divided by 5.0 to get 1.7. And for division rule, you need to subtract. 4, you need to subtract with 9. Then you get negative 5. Okay, dimensional analysis method of solving problems. Determine which unit conversions are needed and carry units through calculation. If all units cancel except for the desired units, then the problem was solved correctly. And given quantity and times conversion factors equal to the desired quantity. Okay, conversion of units and factor label method. Okay, here is the factor conversion for mass, length and volume. So here you need to memorize. A conversion factor is the fractional expression of the equivalence. This is fixed. Here is 1 in divided by 2.5 for cm or 2.5 cm divided by 1 in. It depends on how you want to cancel the unit. Okay, how many cm are in 26 inches? Okay, given quantity times conversion factor equal to desired quantity. So the given quantity is 26 inch times conversion factors. Conversion factors is in inch and cm because you want to convert from inch to cm. So you need to use conversion factor in inch and cm. So you want to cancel unit inch, so you need to put inch unit at the below. So divided by inch because you want to cancel the inch. Cancel the inch, so 1 inch equal to 2.54 centimeter. And you will get 66 centimeter because you will ask madam why we want to put inch at the below of this line because you want to cancel the inch unit. And for the example, calculate the height of a 5 foot 10 inch man in cm and meter. Answer to 3 significant figures. And this is the factor conversion for feet to inch. So the given is 5 feet times, this is the factor conversion. 1 feet equal to inch. Because you want to cancel the feet unit, you need to put feet unit below this line. So you cancel this unit, then you get 60 inch. So 5 feet 10 inch is 5 feet is 60 inch plus 10 inch, you get 70 inch. So please proceed with question number 2 and 3. Okay, question number 2 and 3. So here, given question is 70 inch. How to convert to cm? You need to use this factor conversion. And at the end of the calculation, you convert to 3 significant figure. So the answer should be 178 centimeter. Here is a simplified version. 1 meter equal to 100 cm. Because you want to cancel unit for cm. Okay, liquid nitrogen is obtained from liquefied air and is used to prepare frozen goods and in low temperature usage. And the density of the liquid at its boiling point is negative 196 degrees C, or if you convert to Kelvin, the value should be 77 Kelvin. And this is the density of the liquid nitrogen. And the question asks you to convert the density into kilogram per meter cubic. It wants you to convert from gram to kilogram. So finally, how to convert? Okay, 1 kilo equal to 1000 grams. So you cancel the unit. Here is 1 cm equal to the power of negative 6 meter cubic. So centimeter cubic, meter cubic. So you get the answer is 808 kilometer per meter cubic is the density of the liquid nitrogen in this unit. Thank you for today.